Hello everyone and welcome to my YouTube channel. My name is Marios and I will be your host on this tutorial, which, as you may have already understood, will cover Serverless Framework. Before I start talking about Serverless Framework and what feature it provides to us, let's make a step back and try to explain the idea of serverless computing. And so far the developers, we had too many responsibilities when it comes to building a service, and some of those responsibilities were to build the service, which and to provide the business logic and build any necessary functionality which will make sure that we provide the business logic, test the application, monitor it, and manage resources for it after we deployed it. So the idea of cloud computing is that we remove some of those responsibilities from our shoulders and we push them a layer down, which is the cloud provider. So the cloud provider now provide a great variety of services which we can take advantage of, put all the pieces together and build our own services. From our side, we are only responsible to manage the business logic, and the cloud provider will make sure to run the service, take care when the resources need to change or when we need to scale it up or scale it down based on the traffic and those kind of scenarios. And that's the whole idea. So now, to support that paradigm, we need to have some good tooling as well, and there are multiple tools available to build a serverless backend from scratch. But the most famous one and the most frequently used is Serverless Framework. So Serverless Framework is currently on version 3. So at that time that I'm recording a video, it's on version 3. It has been released, I think, a couple of months ago, and it provides us the right environment, the most complete environment to build our services locally, test them, and deploy them to a cloud provider. The three most famous cloud providers are AWS, Google Cloud Platform, and Azure. And for the purpose of this tutorial, we'll be using AWS, which is the most famous one. Now, let's explain what we'll be building on this crash course. And from my point of view, the easiest way to learn something is to get your hands dirty. And this is exactly what we'll be doing. So we will be using the Serverless Framework to build a CRUD Todo API where users can list items, create, update, and delete items. To support for our implementation, we will be using services such as Lambda, API Gateway, and DynamoDB. And one more tool which we'll be using is LocalStack. And LocalStack is an emulator of cloud providers, of the services provided from a cloud provider. So a common issue that you encounter when you start working with serverless is that, let's say that you need to build an API with a few endpoints, then so the first step you will be doing is to just try to write some code to fill the business logic for one of those endpoints. So when you finish writing that code, you deploy it to your cloud provider and test the behavior of it, and then move implementing the rest of the logic of the API. This procedure is a bit time consuming, and having tools which make development much quicker and save us time It's what we need as developers, and local site is one of those tools, which essentially make us allow us to skip the step of deployment and having a local site container, a Docker container running locally, which our API gateway can interact with it, and we don't need to deploy anything. The whole development happens in our local environment and save us a lot of time. To achieve that, we would be using Docker Compose to run our API gateway into a container and run local site in another container with all the cloud provider services, and the API gateway can interact with that container in our local environment. Without further ado, let's start with that crash course, and the first thing we'll be doing is to initiate a serverless project and have a first look of what is provided to us. Now let's create our project of the To Do API, and we'll be using a serverless command line to achieve that. So I have installed the serverless command line in that environment. We check the version of it. So I'm currently using version 3.2, and if you haven't installed it, the easiest way to install the serverless command line is using npm install and g flag to install it in a global environment, and then just set serverless. So this will install globally the serverless command line, and you can interact with it, and it would give you any sort of functionality that you want. So as you see, using the help flag, we get a display of all the commands available from it. And for our case, we will need to use create, and create is available over here. So let's see what else we can do with create. And one option which we can pass to it's the template, and there are pre-configured templates which we can use to build to initiate the project. And in our case, we'll be using TypeScript, and I would be using the AWS Node.js TypeScript option. And for that reason, I'm just setting template, the name of the template, and path. I need to set the name of the path, and that will be To Do API crash course. So I need to wait a bit until it initiates the project, and after we finish with the creation, so as you see now, we can open that folder using Visual Studio Code, and here is everything we have now. So let's explore of the template and see what is available to us. So the first thing that we can see is that we have a serverless TypeScript file, so that's a configuration file, and essentially tells to serverless what options you need to fix. We see that we have some ESLint issues, and that's because we haven't installed Node modules yet. So for that reason, I am using the nvm.c file, which is already set the Node version that I need to use, and I'm just running npm install. After it finishes with the installation, those errors will go away. And so these are some of the options. Service is one of them, and is the name of the app that we provided. We say the version of the framework, plugins that it currently uses. So we see that we use serverless ESB, and one great feature provided from the serverless framework is that we can extend it by using plugins, and in the later phase we will see how we can extend it to run locally. We have the provider, which is AWS, the runtime that we want, we can set options like memory use, and that tells the memory that a lambda will be used to execute logic. Some options for the API gateway, the environment variables that are available to each lambda, the functions, so those are the lambdas that we create, and a few other options which we don't really care about it. So let's try to have a look of what that hello function is doing. So here we are creating an object with a handler and an event, and the main focus for us is the handler.main, and here is the logic that we provide for our lambda function. So that's a simple hello lambda, and we return a message of hello, the name that we provide to it, welcome to the existing serverless world, and the event that we pass to it. So to run it locally, we need to use a plugin, as I said, and one of those plugins is Serverless Offline. So I'm installing that plugin, and to make the configuration aware of that plugin, I need to update the config and use Serverless Offline. After we finish with the installation of the plugin, we can run two new options are available on the serverless CLI specific to offline, and let's have a look. And we see at the bottom that we have two options, and those are offline and offline start. And if I go in the package JSON, update my script and put a new entry of start dev, and I'm just simply saying offline start, right? And now if I run npm run start dev, we see an API gateway running with an endpoint. One of those is the dev hello, and I will be calling that endpoint to see the response that we get. So that's a post. I'm copying the endpoint, and in the form, in the JSON option, I need to provide a name. The reason that I need to put the name is because here in the event body we have the name, and let's say hello John. And now if we call the endpoint, we see that we get hello John and the payload that it passed in our lambda function. That's good, but let's do some adjustments of the template and bring into the way that we want it. And one of those adjustments is to update the serverless TS to a YAML file, which essentially will help us to get rid of some of the code that we have over there. So personally, I find it unnecessary because that code could exist in the serverless file and provided as a configuration. So I think it's easier if you have a serverless YAML file, and I'm just going to move any configuration from the TypeScript file to the YAML file. And here I'm providing the name of the service, framework version, the plugins. We have serverless ES build, we have serverless offline. Hopefully I don't do any mistakes in terms of typos. We have name, we have runtime, so that's Node.js 14.x, memory, 128 gigs of memory. Let's set the compression size. Should start name with service to true. Let's set the environment. I'm just going to copy the environment variables and trying to adjust them. And next we move into the package individually to true. I left functions for the end. Let's set the custom configuration, so that's build bundle true, minify to false, source map to true, exclude, to AWS SDK, so we don't need the single codes, target, node 14, platform, node and concurrency to 10. And now let's try to set the functions. So at the top we need to set the name of the function, so in our case it's hello. We need to set the handler, so that's the location of the handler, and that's the source, functions, hello, handler, and inside of it we export the main. And now we need to set the event, and we'll be creating an API gateway, and the way to tell to the Lambda that it will be triggered based on API event is using the HTTP option. And a few options that we need to set is the method, that will be a post, and the path, and that's hello. Cool, so that's everything over there. Now if I try to remove the serverless TS, remove it from include here on the TypeScript JSON file, we don't need the mock, we don't need the index as well, neither the schema. So now if I move here, I can remove the schema, I can remove the type because we will include it in a later phase. And if I try to run, let's see what we get. So we see that it's running, and if I repeat the same code that I did before, we still get the same output. So it means that the changes that we did, they were fine. Now let's try to organize a bit what we have over here. We have Midify, we can move Midify into API gateway, and we need some imports, and let's copy those inputs over here as well. We can remove the Lambda. We have the handler resolver, which we are not longer use, and we see that we have only a single file, which is good. Those types are not used anymore. We can remove them, and we will create our own types in a later phase. We can remove the JSON schema to TypeScript, and we have all those over here, and we can import them, modify over here, but I think a much better name, it would be new handler. So essentially we pass it the handler, we wrap it within the MIDI function over there, and extends it, passing the MIDI JSON body parser middleware. So that middleware essentially parse the string of the event into an object. So when we access the body, that will be as an object, and that save us from doing the actual parsing. So now if I come here, update it in handler, so we still see that it's running. and let's try to restart the API to see if it picks all the changes, and yep, everything is fine. I said that we need to create some types, so now let's move into types, and the first type we'll be creating is we need to get the type of API or API gateway proxy event. We need this one, and we also need proxy result, so we need those two. So I will update the name of this one to be request, right, and this will be response, and we're going to have a type for the handler, and this handler will accept the request and return the response type. And if we check in the type of the API gateway proxy event, we see that the body will be a string and null, so we need to update it now that we're using the middleware, and it's easier for us to also like provide some correct types to the path and parameter and accuracy parameters, because if we see here they're just simply objects and we won't get any auto completion support, and we like TypeScript and we want to get the auto completion that provide to us, and we need to do something like that, and we'll be using generics, and this extends an object and will be an empty by default. We also need to set the path, which is unknown, and query, which is also unknown, and we overwrite them, and the same for cursing parameters, and that will be key. So that's how you extend it and pass the right types based on the type of the request. And we also need to provide those types in the request, so we're gonna extend handler to the generic and pass all the options down to the request type, and that's what we have. So the response will be a promise. So, and now if we move into our handler, we can input the types, and let's come here, have handler, and pass handler over there. We see that we get an error of the name, and that's good because we haven't set the structure of the body. So now if I say string name, you see that the error goes away, and that makes sure that TypeScript is working okay. And let's repeat our call. You see we get a valid response. We finish adjusting our template, and now let's proceed explaining the architecture and the structure of the API. So I will be creating a diagram for that. I'm using draw.io, which gives us a nice interface for us to create our diagram. So at the front, we will be having an API gateway, and I'm just setting API gateway, right? And that API gateway will be connected to multiple lambdas, which would run as endpoints, and one of those endpoints will be get API v1 to-dos. So that's one endpoint, and let me make I made it a bit slimmer. One other endpoint will be to get a single to-do item, and that's using a GUID. So we can pass a GUID, and that GUID will be processed within the Lambda, and Lambda will reach out to the DynamoDB database to fetch the to-do item. If it can't find anything, then we return a 404 status code. If we find the to-do item, then we return to the user. The third endpoint will be a post, and will be on the API version 1 to-dos, and what we will be doing on the endpoint will be to pass the body and extract the body within the Lambda and try to create a new to-do item in the DynamoDB. If we encounter any issue, then we return 500 status code. If the submission is successful, then we return a 201 status code with tell us that a new to-do item has been created. In addition, we return a header, a location header, which tells a new location of the to-do item. The fourth endpoint will be a put HTTP method, and will be updating a to-do item, and for that reason we need to pass down the GUID. So the logic within the Lambda will extract the GUID, will extract the body, check if a to-do item is already available, it's available. If not, we return a 404 status code, and we don't proceed updating the to-do item. If a to-do item already exists in the database, then we proceed with updating that to-do item with a new body that we pass in our Lambda. And when we finish the submission, and if everything is okay, we return a 200 status code. And last but not least, we will have a delete endpoint, and that endpoint essentially allows us to delete a to-do item, and if we successfully delete an item, then we return a 204 status code. So we have the API gateway, which sits at the front of our Lambdas, and we also have a DynamoDB, which sits behind the Lambdas, and this DynamoDB, I'm just going to put DynamoDB, and within the DynamoDB we're gonna have a single table. Let me connect it with the table, and that would be a to-dos table, and that would be the environment, so it's either going to be dev or short. And one item will be grid, which will be a string. Another item is a title, which also is a string. We will have an option to tell if the to-do item has been completed, so let me set it to Boolean, and we're going to have one more option, which is create an add, and that would be a string, and it's just going to be the date of the creation of that item. And all the Lambdas will be able to communicate with Dynamo. Let me create Sarus, and this would be the setup of our serverless backend. It's a very simple architecture, the most basic one, but it gave us it will allow us to interact with API gateway, Lambdas, and DynamoDB services, which are provided from DynamoDB, which are provided from from AWS, which are provided from AWS. Now let's export this diagram, and that will be a PNG image. And if we open it here, we see the diagram. And before we start creating the controllers and the lambdas, I like to create a collection in that plugin that I'm using in Visual Studio Code from the client, which essentially will allow me to easily switch between each of the endpoints without me trying to rewrite them every single time to test my calls. And it also allows me to organize everything that I have really well. And so I'm creating a collection that this would be to do API, and in that collection I need to set some requests, and one of those is get to do's. So it will be all the requests that I have in my diagram, and those will be running on localhost 3000 dev to do's, dev API v1 to do's. So I forgot to include the dev in my diagram, but all the environments, they are prefixed with the stage of it. And when we say stage, we mean the environment that will be running. So if it's dev, then it's dev. If it's prod, it will be prod. And that will be one of the endpoints. And we created it over there. Let's create one more for get to do. And I don't need this anymore. Seems that I didn't save it correctly. We want to do, I keep forgetting the environment. And if I move with the get to do, and that would be a GUID, and we're going to have a GUID. We also going to have a post to do, and that will be a post method, and we don't need the GUID of the item. We also need a CRUD to do, and we need to pass a GUID. In that case, I'm just passing one now because yeah, the GUID it's a bit long, so, and I'm not in the mood for search for one of it, other than we're going to generate in a later phase, and I can pick this one. And I also have a delete to do, and that's for deleting an item. And if we check what we have created, so we have a delete, we have a put, a post, get, and get do's. So all of them, and we see that what all the endpoints they share is a base URL and the stage. And for that reason, I will be also create an environment, and within that environment we will have a base URL and a stage, and I set it to dev. So after I deploy the API, I can easily come over here and update those options, and it will point to the prod endpoint rather than me manually updating all of those. And to get rid of to reference any value that we have in the environment, we just need to set the base URL, which is something like that, and stage. So we need to use two curly braces, the name of the environment of the variable, and close it with two curly braces. So we didn't pick it, and the reason is we need to set the environment that we will be running. And if I come here and set the settings, environment, I want to set my environment, save it. Now if I come into CRUD To Do, we see that it highlighted the change, and that means that it picked the environment variables that we created. So now I can come here, update this, go to this, and let's create also one for hello, and we will remove it later. And the only reason that I'm doing it is so I can test that the reference of the value is correct, since the API gateway is running and it couldn't find it. And the reason of that, it's because I'm making a GET request. So if I update it to post and pass the right JSON, and let me set it to 9 and Jan, and save it, send, we get the right response. So we created our collection, and now we're able to proceed to the next step, which is to create the functions that we want over here. The next step is to create our controllers. So currently we have only a single controller with the name hello. I will be creating a directory with the name to-dos, and within that directory I will create a TypeScript file with the name get-to-dos, and I'm simply going to copy the code from the handler, and here I'm going to call it base handler, and the output would be handler, and we see that we use a format JSON response, and I think we can improve that, and what we can do is to create a factory, and that factory to return the response, the structure of the response that we have. So this will return something like that, and this is a response, and we need to return a response. So the response has a status code, and this will be passed as a parameter. We also need to pass some data, and let's set it to any, and we also need headers, which would be an object of string with keys as strings and values as strings. So I'm casting status code, so we won't have any base 64 encoded. We need to pass a body, so we need to string define body. We need to pass and ascii headers. So in our response, let's have a look here. In the body, so if I update hello, okay, and set something like a string, which let's say that would be the case when we get an error, we see that we get only like a string. And when I build APIs, I like all the endpoints to return the same format, and for that reason I create a type which forces that format to be consistent between all the endpoints. So for that reason, let's create on the body we need to return a specific type. So that type would be status number success, which tells if the response is successful or has failed, a message if there is an error, so that's optional. In data, if there is a payload that is returned from a successful response, and that would be D, it's a generic, okay, and we have a body, and it shouldn't be here. It should have been into my get to's where everything is located at the moment. So we get data. So data can either be a string, an error, and or a valid payload that we want to return. So we need to have a logic that processes the data and extract the right information from it. So essentially it's a type code in TypeScript. And what we can do is pass the status code, process the status code. Based on the status code, we can evaluate. Okay, if it's like a 400, then it's either like a string or an error. Then if it's an error, extract the string from the error and create the body type that we want to return. Or if it's a valid response, then just pass the data and skip having a message, populate the message option in the body type. And for that we need one more utility, and let's call it evaluate data. And as we said, we're going to have a status code and data which is sunny. So we need a switch case and a status code. I will create a dedicated type for status code to make it more clear, and also create some variables which reference some status code. So let's say that we have status. Okay, that's status code, and that's 200. Status created. Status no content. So we need that status code when we delete a to-do item. But request. So if we pass we pass an invalid body to the request payload. So that's 400. Status not found. So that's 404. And internal server error. I don't think that we will need any other status code, and let's evaluate those status code. So in the case of status okay, and in the case of status created, so what we return here is a body, right? And we set status code success to true. We don't need to set the message, and data, we just pass data. Then we need to check the no content. So in that case, we don't need to return neither data, neither a message, only status and success. Success is true, and the default we assume will be a failure, and that we has the status code success to false and message to something. So when we call the factory, we make when we call the new response factory, if it's a failure, then we either going to pass an error or a string. So we need to evaluate the type of it. So we create a type predicate, and let's say data and data is error. And if it's an instance of an error, then we know that's an error, right? So if that's the case, of our data, then we know that's an error, and we see that we got the auto completion from TypeScript. If otherwise, we know that it will be a string, and we explicitly cast it to a string. We have evaluate data, so now we just need to call that function and pass the status code and data, and we are good to go. And if I update the format JSON, and let's say something like that, and the message will be get to use. We need to make the headers optional, so I'm just going to have a fallback value. Now if we had an issue with there, and I will also be moving that code inside the API gateway because it will be reused by the other handlers. Right, and if I export it, we want the response to be imported. And let's have types and response. We saw that the errors went away, and now we can import it here, which is new response. We only need the handler, and let's restart our API. And we got an error, and that's because we're trying to import the format JSON in here, and let's avoid it, and in the hello just pass a message and hello world, and let's rerun the endpoint, and now we'll be able to check our get-to-do's controller. So call hello, we see that we got a nice structured payload which tells us exactly what we get, and data if there are any data in the response. And now I can check my get-to-do's. I see that we have an issue over here, and that's because we haven't updated our serverless YAML file, so I need to populate it. But before doing that, let's create all our controllers. I believe I can control the hello, because that was only for us to demonstrate the initial setup and what we can do with it. Now we can replicate, we can copy the get-to-do and adjust it for the get a single to-do item, and I don't need that at the moment. Get single to-do. Okay, let's copy that. Post to-do. And that will be a post. We also have CRUD To-do, right? And the last controller, it will be delete to-do. We have 5 of them, and that looks good. We don't need this anymore. And here, simply we are going to export all of them to-dos. So get to-do, we know that we export them as handlers, and we'll rename them. So that will be get to-dos, CRUD. Then we have CRUD to-do, and the last one is post to do, and we have all of them over here. So now on the top level, I know that I have everything. So you can also create that index file over here and export them. And in the top level index file, you simply can export everything from to-dos. So I think that provides like some sort of scope of what that module is doing and makes things more clear, but that's personal preference. So now we can come into our serverless YAML and update it. So within the functions segment, we can set the Lambda functions that will be running, and we can connect those Lambdas with the API gateway. So the first Lambda will be get to do's, and I need to update the handlers because now it lives into the functions index that get to do's. The method that's a get, and I need to set to API view on to do's. I can copy, or let me write it. Let's do some writing. Get to do, but the auto completion doesn't help us over there. Functions index get to do, so that's events. We need to set the method, that's a get. We need to set the path, that's API view and to do's, and we need to have a parameter, and you can tell to Serverless Framework that you're going to have a dynamic parameter with the name CRUD using curly braces. So that means that when you come into event to do here, right, and set a no and set the type of it, and that would be CRUD string, we know that when we check in the event path parameters, we get GUID, and it will be available to our Lambda to populate any business logic that we have. I can copy this and I can set post to do, that's a post, and I don't need a dynamic parameter. I also need a put to do, so that's put to do, that's a put, and I need a dynamic parameter, and I need a delete to do, and that's in the handler should be the index.delete to do. So you may be wondering why I add the name of the file and then dot and the name of the export, and that's a way of how I tell to the serverless framework that you need to come into the index file, and because we are doing the export over here, so from all this export, then pick the delete to do function to execute the logic that you want. So we managed to set our functions. So now let's run the API, and also we can test our collection. So we see that we get some issues, and there is some conflict with our routes. And so if we go into our serverless, we see that there is a conflict between the delete and between the put HTTP method and the delete to do, which was also using the put. So I have to do to delete, and let's review again what we have to avoid any similar issues. So now if I rerun it, we get all the endpoints. We see that serverless give us a nice view of what it's running and what's available, and that's if I put the diagram that I created. At the top, we see that we have API v1 to do's, so we ignore the stage, which is dev. We have API v1 to do's, and we pass it through it. We have API v1 to do's. We have API v1 to do's GUID for a put HTTP method. And we also have API v1 to do's and the GUID for a delete HTTP method. So we cover everything we have in the diagram. Now let's make a call to each of the endpoint. So we get to do's, we get a single to do, we post a to do, we put a to do, and the last one delete to do, and we see that slowly everything comes into place. Let's move on, and we test that we can communicate with our endpoints locally. But if we have a look into our lambdas, so they are empty, and here we need to populate the business logic and also communicate with AWS, with any other service that we want to interact with it, and in our case is DynamoDB. And the way to communicate with those services is by using an SDK, software development kit, and AWS provides the AWS SDK. And if you want a specific to get a client of a specific service, then it's just client minus and the name of the service. So I need to install it, and after we finish with the installation, we're gonna get access to a client which we can initiate and run different commands that allow us to interact with the DynamoDB service. So I think it's good to create a module. Let's call it AWS module, and here we're going to have an index.cs file which will import a DynamoDB file that gives you abstractions that you can use to create the to-do item to handle all the to-do items that you have. And the first thing that we do is to import the module. We see that we have a DynamoDB client and I need to initiate it, but I won't be doing it now. In a later phase, as a start, I will create a new DynamoDB factory. So we'll be calling that function and return a structure of that assembly type of that module, and we need to create that type. I will call it new props or result, let's call it, and here I want to have find one to do, so that will be a function that will find one to do item, find to do's, that will find multiple to do's. We want to delete to do, and we also want to update or create a to do. So this type will be returned by that handler, and I need to somehow fit that logic. We see that we get a lot of warnings at the moment, and I need to create those functions that will be exported from that module. So I would set something find trying to do, and the first parameter of the location would be the DynamoDB client, and here it's any parameters that will be used within the lambda. So to find one to do item, I need to pass a grid of it, and this will be a string, and if I come here, I will wrap it within a try and catch and return the appropriate response. I also need to create a type which I will call resolve, and that will either, so it will be generic, and by default it will be an error. So the result will either be an array of an error or an array of undefined, and the data that I'm returning. So we see that the first parameter is either going to be an error or undefined, and the second parameter will be the data if there is a successful response, and passing it here. And in the final what to do, I'm returning a promise because I need to do something asynchronously. And here what I'm returning is a to-do, so I need to create the type of the to-do. So as we discussed before, it would be a grid title completed and created at. And if you are not sure how I got that, then look into the diagram, and that's the table that we created over there. And we need to return something like that. So if there is an error, then I'm just returning an array of the error. And here for a successful response, I need to return undefined and date some sort of data if I type undefined correctly. So the module, the AWS SDK, provides us a lot of commands. So one of those commands is get item command, and we need to instantiate that command. So that's a class, and we need to instantiate it, and we see that we need to pass some inputs, and one of those input is this table name and key. And here I need to pass table name, and that will be to-do-dev. So at the moment we hardcode that value, but we need to pass it as an environment variable. So that's how I go to this dev. And we need to also pass a key. So on the key, I need to set grid and the type of it, the value it. So that's a way that you need to pass a key using the AWS SDK, and you can check the type and verify that. And the next step is to use the client and send that command and wait for the response. And we get some sort of response, and within that response we have an item, and that item, if it doesn't exist, then I need to return a 404, and I will create a specific error for that. Error not found. Right, so I can reuse that error in the other utilities that I'm building over here, and if I can find it, then I just return that error. And the next step is to map the item to a to-do item, and for that I will create map item, a utility that will get the item that I get from the SDK and map it to a to-do item. To-do item. So the item, it's a record of string and attribute value, and let's make sure that this is inputted, and I need to return a to-do. Here I need to return a to-do, so one of them is grid, so grid, and that's would be a string. We have title, we have a created that, and we have the completed, which is it's a bool. So you may be wondering what are those types. So when we create the DynamoDB table, so for each of the keys, so in our case we'll be creating a DynamoDB and set a partition key to to be the GUID. So the GUID would be a string, so s tell us that it would be a string, and for example here it's a boolean, and that's the structure of the item that we get and how we convert it into a to-do item. So now I can use that utility over here and map the item so that I get the to-do item. And we finish with the implementation of the find, run, to do. Now let's copy what we have here and set the implementation on find to do's, right? And here I need to return an array of to do's, and I don't need to set a key, and I also need to update the command. So to get all the items from a DynamoDB table, we need to use the scan command, and we can replace it with the get item command over here. And if we want to see what other options we can pass to it, you see that we can pass index name, limit, so we can tell it exactly the size of the items that we want to return, and we'll be using it. So let's import the scan input item here, and in the find to do's I will update the grid to get a few options, and I will omit the table name, but in the options we can also get the limit, and I will spread it down over here. So we get items, so that's a list of items. So if the length of that list is 0, then I return an error not found. Otherwise I need to return the to-dos, and I will set a variable of the to-dos with items.map and map item to do item. So we get the find to do's, where we finish with the implementation of this one as well. So we get errors here. Let's update our types. So we can use the return type option in TypeScript to get the type return for a specific function. So in our case it would be get type of get one to do, or find one to do. I was wondering why I don't get here the condition, and find to do's. So essentially what is it doing is invokes a function. So the first invocation is passing the client, and the type that we set over there is actually everything after the async. And here we get find one item, so I need to pass a client here. I'm just going to show you how we start structuring our module, and what I'm looking here, I'm looking for the DynamoDB client, so I need to initiate it and pass it down to the function that I created. So now I can set the find to do's and find to do's, and I also need to have a delete to do, and let's move on implementing that delete to do. I'm copying the find run to do, and let's actually call it delete run to do, and put it over here, and let's update the name to something like that, right? And here we accept a GUID. We need to update the get item command to into delete item command, and we update it here. We set the key, and we don't expect to return anything, so we don't really care about what we return. So we either want to get an error or a define, and here I'm just returning define. and I don't need to make the check over there. We finish with the delete one to do, and now let's proceed with the put to do, put one to do, and here we need to update the command. So I will be using put item command, and what I need to do is to pass an item. So I need to, so if we inspect the item, we see that that's a record of attribute value. So far we have been converting the item we got from the SDK to a to-do item. Now we need to do the reverse procedure. So pass a to-do item and convert it to an item that is accepted by the SDK. So I will have something like to-do, and that would be a to-do item, and let's set something like map to-do item to item, and the parameter that we accept is a to-do item, and we need to return an object of with key of string and the value of the type of attribute value. So now I need to iterate over the to-do item, and I will use the reduce function to construct the item. So the first it will be the item, and here we're going to have the name and the value of the to-do item. So at the bottom we will be returning the item. So we will be returning the item, but we need to extend it by having the name and the value. And the value here, it's not the plain value that we have. We need to check the type of it, and based on the type create something similar of that. So it should be an object with the type of it and the value. So I will create a utility with the name map value to attribute value, because that's the type of the attribute value, and here we set the value, which will be any, and we will pass it into a switch case, and case type of, if it's a boolean, let's say. So in our case we have two different types, boolean and string, and if it's boolean then just set bool and the value, and for the default case just set return and the value, and here I need to set it to attribute value, and I want to make sure that the auto completion is valid, and we see that everything is fine, and I need to wrap my value within that util. So yep, that's how it's it at the moment, and let's use that utility and pass the to-do item to it, and we create our command. So we make the call. If the call is successful, and then we can continue finding that item and return it. So for that item we need to pass a GUID, and we know that we return an array with the first parameter to be an error. to-do item, and if there is an error, then simply return it. Otherwise, return undefined and the to-do. And I would rename it to new to-do, or I think it would be more intuitive if we have body and find one to do, and we get an error, and that's because we haven't updated the type here, and it should be a to-do, and we still get an error. Find to-do, next body, that's good. Up, and the first argument is to the client. So that we solve the issue with the type. Now we can come over here and update and finalize what we have with the type of the new DynamoDB factory result. And that's delete one to do, and one to do, and that's client, and we have everything over there, so everything is good. We need to export it, right? And trying to think if we need anything else to export. We have the error not found that is exported. We can move those two into the types because it will be reused by other files as well. And here at the top we can import those types. And to do. And we are done with the implementation of the DynamoDB file. So here we simply need to import the DynamoDB file. We need to import the factory. We can export everything. Here we simply have something like DynamoDB, and we invoke it, and we make it more explicit of the type. And now we come into the to-dos. Let's say we can import that module. Come into AWS, and here we have AWS, right? And if we call the AWS, we get DynamoDB, and we get all our methods that can be reused within our lambdas, which is a really nice way to abstract logic into a module and use that module to give you all the core functionality that you will use within your controllers. Before we feed the logic within our controllers, we need to have a DynamoDB instance, and as we said at the beginning of this crash course, we will be using localstack. So localstack will simulate the AWS environment, the environment of the AWS services locally, and we can communicate, and we would run it as a container and communicate within that container to interact with the DynamoDB service. So before we start writing our Docker Compose file, we need to create a Docker files for the API gateway. So we need to containerize the API gateway, and for that I will be creating a Docker Compose file. And if we open that file, I need to set a few options. So we need to find an image, and the image we'll be using is Fermium Alpine 3.14, so I would reference that version at the top. I need to set a directory and initiate directory, so that would be API. I will set as command that will be executed when we run the image, so that's npm run start dev. We need to expose a port, so the port that the API is running is 3000, so that's the breadth of that Docker file. Now we need to create a Docker Compose file and try to run the API gateway as part of the Docker Compose. The first thing that we need to set is the version, and the version we'll be using 3.9. We need to set the services, and that's API gateway. The name of the container that we'll be running, so it will be to do API crash course API gateway. We need to set the build command, so we need to build the image, so the name of the Docker file that will be used to build the image. We need to set the context, so the context in that case is the current directory. We need to set the name of the image. I would set course API gateway dev, so that's after we build the image, the name that it's assigned to it. We need to set some ports, so we set that's 3000. We need to set some volumes, so in the Docker file we didn't copy the application, so usually you will copy your application within the Docker image, but in our case, because we want hot module reload to be enabled, will be mount the volume of the API gateway within the container, and we will be able to, and the service will restart whenever we do the change in our local environment. So that would be on bind volume. The source will be API. The source would be the current directory, and target would be the API. And let's try to test it, and let's see if we missed anything. So if you run docker compose config, then it will check the config that you created, and we see that the config is valid. So now if we build the API gateway, let's see what we get. So it needs some time to build the image. And now let's run the API gateway service. It created a network, and what we want is actually to create our own network. And for that reason, I would set a network crash course API, or simply I would say backend. That would be the backend network, and the name of it would be what I was trying to type, network, and I will assign that network to my service. Now if I try to restart it, we see that it creates the network, we set it, and the API gateway is running. If we try to interact with it by calling one of those endpoints, we see that we get an error, and that was intentional because by default the serverless offline plugin runs on host, or runs on localhost, so it listens only to localhost. So to make it listen to all the available IPs while it's running in the container, we need to update the serverless configuration, and that's on custom, and here we need to set the serverless offline option, and host we need to set to all IPs. So that means that it can listen requests that are coming from us. Now when I rerun the service, we make the call and we get the valid status code. The next step is to run local start as part of our Docker Compose. So I have a few images already downloaded locally, and you will see here we have a light version of the image and a full version, so I'll be using the light version, and I need to update Docker Compose to include to create the local stack service. So I would name it to AWS because essentially it will run AWS locally and me interacting with the services provided from it. The container name will be to do API crash course AWS. The image that I covered before. We need to export some ports, and local start runs on port 4566, and it's easier for us to check this if we open the configuration of local start, and if I move at the top, there are some environment variables that I need to set, and by default the edge port that the service is running it's 456. We also need to set services, and the service that we'll be using from our side will be DynamoDB, and we also want to set data directory, so that's the data directory that all the data of local start is stored. And we need to create a volume so that we don't need to recreate anything that we have on every rerun of Docker Compose. So we need a volume for that. So let's proceed adding those few things that I mentioned. So we have edge port, and we export this one. We need to set some environment variables, and one of them is service, and that's DynamoDB. We also need to set the data directory, and it's on temporal local stack data. For that we need a volume, so I have volumes, and I will call it AWS data. And to reference that volume, I need to populate the volume section. So tag will be a volume, source AWS data, and target temporal directory and data. We want to update API gateway to depends on AWS, so it runs only after AWS finish, and we also need to set a network to it, so that would be the backend, and one more thing we need to set is Docker, and the Docker socket that my environment is currently running, and the default Docker socket it's on, let me put it over here, it's var run Docker socket, and in the target I will also set the same, so I'm just creating a bind volume of my socket of my host machine into the target local stack container, so that it's also able to run Docker within it. And one more thing that we need to set, and I forgot, is in the volumes on API gateway is to create a bind volume of my AWS credentials. So by default the serverless will pick anything that you have within the home AWS directory. So you see that I have a few things over there, and I have a few credentials. Let me set something like I have credentials as well. So we need to make a bind volume so that I mount those credentials within the container, and when API gateway can run, I can recognize some credentials. So for that, I will be doing that mount over here, and I will reference root AWS if I type root correctly, and we are good to go, I believe. So now if I try to run Docker Compose up, we see that both of the services are running, and the easiest way to check this health status of local start is to just run home, and we see that we get status of running. Then you can also check health, and you see all the services that they are running. And one more thing which we can do so is to verify that DynamoDB is running, and we can use the AWS CLI, set DynamoDB, and a target endpoint URL. So by default, we'll communicate with the prod environment of AWS. So in our case, we want to communicate with our local stack instance. So for that reason, I will set something like localhost for end the port of local stack. And I didn't set the command that I want to run, so the command that I want is list tables. And we see that we got some activity over here, and we get empty because we haven't created any table name. So let's now proceed with creating our DynamoDB table. We'll create a README or remove the content of the existing README and set something Serverless Todo API, and here we set the setup, and within the setup set the commands that it will be running. And I'm copying this command. I will set the endpoint URL to a variable, and I will reference that variable over here. And in our case, we want to, so that will be the command that we will run to verify that our table has been created. But before that, we need to create the table, and we need to check that command, what we can do with it. So now I can run help, and we see what we need to run. So create table, we need to pass attribute definitions, table name, and key schema. So those options are required. So the first option that I will be passing is table name, and we'll create a variable for that, AWS DynamoDB type todos table name, and this would be todos dev. And we also need to set attribute definitions, so that will be comma separated values of attribute name to be GUID, and attribute value to be the type of it, and that's S. So if we explore that and move into that the description of that option, so we see that we have attribute name and attribute type, and that's the string. So it's either string, and on B that's for binary. Now let's move with the key schema, and the key schema also accepts an attribute name, which is also GUID, and we need a key type, which is hash. And here you can see key type, it's either a hash or a range. In our case, it's a hash. So essentially tell us that we're gonna have a key value table with keys to be the GUID, and all the values, anything else that we would reference for the to do, anything that related with the to do item. So we can also set provision through output. So that tells how much it would cost us an interaction with DynamoDB. So for example, when you try to write something, how many units it would cost us by doing that operation, and the same applies when we read information. So by default, there is some cost when we run any operations on the DynamoDB table, and we can't set how much it would cost us when we create the table. And I need to find the options, put, and the options are read capacity unit, that's 3, and write capacity unit, which is also 3. So if I try to run that, what I have type over there, we get an error, and that's attribute type. And I said attribute value, but in reality it's attribute type. And we see that the table has been created. Now if I list the tables, we see that we have the to-do table. We managed to finish creating our table, and the next step is to move into the DynamoDB file. And if we scroll up, the first thing that pops up to us is that we hard-coded the table name, and that's not very efficient because when we need to run our service in prod, we need to update the value to the prod table name, which in that case would be todo's prod, and as I said, it's not efficient. And the easiest way for us to manage different values on different environments is by setting an environment variable. So we will set an environment variable in serverless for the table name. And if we scroll at the bottom, we see that the DynamoDB client has been initiated without passing any options to it. This means that the client will point to the AWS environment, and in our case, we want to point it to the local instance that we have in Docker. And for that, we need to set the endpoint option, and this will be one more environment variable that we need to set. If we move into the serverless YAML file, we can update the environment section, and here we can set AWS endpoint to be one value and the table name, and to keep it consistent, let's get the name that we set in the readme over here. So we need to populate those values, but one value needs to be for dev and another value needs to be for prod. And a new feature available on serverless version 3 is params. So within that section, you can have different environments, and per environment, you can have different values. So in our case, I will have AWS endpoint, and this will point to AWS 4566. And I also need to set AWS DynamoDB to-dos table name, and this will be to-dos dev. So you may be wondering why I use AWS over here, and if you remember, in Docker Compose we have two services that are running. One is the API gateway, which is where the serverless YAML will be available, and the other one is AWS service, which is local site instance that we have. So if we want API gateway to communicate with AWS, then we need to set the IP of the AWS service, and and since we have created a network over there, by referencing the name of the service, the API gateway, we know the network we know to resolve the reference of AWS to that IP. So now we need to fill the values for prod, and for prod we don't need an AWS endpoint, and the table name needs to be to this prod. And to reference those values, we simply need to set dollar curly brace param column and the name of the variable of the parameter that we want to reference, and we need to do the same for the table name. And one more thing that we need to set is the environment, so that we know either if we are either on stage or on prod. And to do that, we need to reference that serverless stage. So by default, serverless, when it runs, it has some default configuration. That configuration includes the stage, which is the environment that the serverless framework is running. So by default, it's dev. And when we need to deploy our backend into prod, we will need to set that stage to be prod. So the value of stage will either be dev or prod, and we can conditionally check within the DynamoDB file to see if we need to pass the AWS endpoint for dev environment. Otherwise, pass an empty value if it's for prod. So let's demonstrate that by coming into the DynamoDB and try to extract those values, create a reference of those values into as variables. And I will put serverless YAML on the side and try to create variables of them. And the stage. So if I miss configuring the table name, I want to throw an error. And the reason of that is if I don't have the table name, then I will be communicating with a table name that I don't know in DynamoDB. So I prefer to throw a runtime error and notify me about the lack of configuration. So please provide a valid configuration, right? And I can update the table name, and I will copy the value over there and replace it. So we see now that the table name is the hard-coded value that we have, which is coming from the environment variable. And at the bottom, we need to update the reference that I have of the client, and I will create one more function which will be named get DynamoDB client. So we will return a DynamoDB client, and if stage equals dev, then I want to initiate the client by setting the endpoint, and the endpoint will be the environment variable that I have over there. Otherwise, initiate it without passing anything. And let me see, do we have an issue over there? And on client, I need to call the function, and everything looks good. Okay, so now I need to restart Docker Compose to update itself with the new values. So let's rerun it. And it's running. And now we can start implementing the business logic within our controllers. So we know that we set the configuration for the API gateway to communicate with the local stack instance. So and we know that we also wrote the utility that we need to communicate with DynamoDB. So now let's try to put all those pieces within our controllers. So on get to dos, we already have the AWS module, and we can call the find to dos, and here pass an option. So we said about passing a limit, but to demonstrate that we can communicate with the DynamoDB, let's pass empty at the moment, and we will fill it later. And we expect to have an there is a possibility to get an error as the first parameter, so I will call it to find to dos error, and here it will be to dos. So if there is an error, then I also need to check if that's a 404 error. Then I will return a status not found and find to dos error. So remember that on the DynamoDB and find to dos, we have a condition that check if items has a length of 0, then return an error not found. So we make a check over here to set the right status code. Otherwise, I need to return a status internal server error and set return the details of the error, and I can return the to dos item, and here I can set status okay, and that's implementation of it. So I can restart my Docker container because complaints for that one over there, and I can call get to dos, and let's call get to dos. Oh, let's wait until the gateway is available, and we get 404, and that makes sense because we haven't created any items at the moment. So let's extend our controller by passing the limit that we discussed. So this would be a variable that users can pass as a query parameter. So if the users want to limit the output to a specific number of to-do items, then they can do it by passing a query parameter. So in that, if they don't pass anything, I will set a default value, and that value will be used over here. We get a TypeScript error, and that's because TypeScript thinks that the type will be either a string or number. And to resolve that issue, we need to update our handler to tell to TypeScript about the right type of it. And I missed the comma, and we see that the error went away. The other thing that we need to do is to update the controller for fetching a single item. So I will be importing the AWS module, and here I need to get a single item. So we see that we need to extract the GUID. We need to pass the GUID, and we need to extract it from the event path parameters. Okay, and we shouldn't allow processing if the users don't pass a GUID. And to validate the path parameters, we will be using a library and with the name Joy. So if you're not aware about Joy, it's a validation library, and the most famous one within the Node.js ecosystem. And let's proceed by installing it. And essentially, Joy allows us to create schemas of a specific structure, and we can use those schemas to check the structure of different objects. And that's exactly what we'll be doing. We will create a schema and that schema will run against the event path parameters, and if it doesn't match the structure of the schema that we are expecting, then it will throw an error. Let's import joy, and we see that we get a TS warning, and that's because we need to update our TS config. And I would set it to true. And now we can create our schema. So the name of the schema would be path parameter schema. And the structure of the schema is we need to include a GUID, and the GUID is a string. It needs to be a UUID, and it's required. So if users don't pass it, then we throw an error. And we need to validate the event path parameters against our schema, and that's how we do it. So the output of that function, it's an object, and one of the properties is error, and I will rename it to path parameters schema, path parameters validation error, sorry. And if we have an error, then we need to return 400 status code. Right. So now since we are sure, we know that in the path parameters we're gonna have a GUID, right? It means that we can pass the GUID within our find when to do, and we can wait for it. So the first parameter would be find when to do's error, and the second parameter is the to do. The to do, we will pass the to do in the response, and here it will be a 200 status code. But we haven't checked the error, so we need to check that the error is empty. So if there is any error, and there is a chance of the error being a not found error, so if that's the case, then I want to return 404 status code. Set the error, otherwise I want to return an internal server error, right? And that's what we have. Now let's move by filling the logic for the procedures, right? And here I will copy those two imports, right? And first I need to create a body schema. So we know that users will pass a body, and we need to validate that body because we need to include the title and completed option which is optional, and we will allow to users to either pass a GUI if they want, and the creation date. Otherwise, we're gonna set some fallback values, and we will use those values. So let's proceed with creating the schema. So here we have a GUID, and where users can set the GUID, and this needs to be a UUID. If not, then if they don't pass anything, then we need to set a default value, and to generate a UUID, we need to use a specific library, and that's UUID. So, and we also need to install the types of it, but that should be a dev dependency. And let's import it. So here we can use a v4 method and rename it to UUID and invoke that method to generate the GUID. So we also expect to have a title, and that's required. We also expect to have completed, and this is a boolean, right? And the default value is false, and we also expect to have the creation date, and the default value twice a string, and that's the body schema. And let's update the type of the handler to match that schema, and I will create a body schema, and as you have already guessed, that looks very similar with the to-do item we created, and I will pass it over here. So the first thing we need to do is to validate the event body, and that's event body, and if there is an error, and we will rename that error body schema validation error. And we also expect one other property is value, and that's the output of the validation, and we'll include the generated values that we set over here. So essentially that's the new body, let's say. So if we have an error, then return a 400 status code, right? And I mistyped the return over there, and status but request, and we need to import it from over here or over here. And the next thing we need to do is to use the AWS module and pass the body down to it, right? So within the array, the first parameter we expect to be an error. So let's investigate let's check if it's truthy. And the second parameter to be a to-do item. So if there is an error, then return a 500 status error, right? And here just return the to-do item. So that's status created 201, and in there we can also set a header. So when we created the new response, there we set a third argument, the headers, which we can populate. So I will be setting the location of the endpoints that users can contact to access the information of the created item. So API v1 to-dos, and that's to-do.GUID. So that's pretty much, we don't need the error not found, and at that point we can test our API, since we can test the creation of a to-do item and also try to get items. And let's try to make a call. So let's first get to-dos. So we test this one, and we saw that we get a 404 because we haven't created anything. So let's have a look on the to-dos over there. So let's check. We see that the validation is working, right? And let's try to post something. And here, let's try to create a to-do item, and in the title we're passing go shopping. So if I try go shopping, we created the item, but we see that we get only the GUID and the title. We're missing the completed and the created art. So let's see if that's the case for the other endpoints as well. So here we get a list of the items, and that we're missing the completed and created art. So it seems that we have a bug somewhere within our logic, and we can also try to get the to-do item from over here. So if I try to get it, we see that we get a 200 status code, and if I try to pass an invalid GUID, then I get a 404. So let's have a look on the issue we have, and I believe the issue is on the DynamoDB file, because all the calls that we did return the same structure. So it sounds to me like the issue is somewhere that we are doing the mapping. And let's try to find the map item to do util, and yep, we have one issue there. So we mistyped the create add, but the completed property seems to be okay. So we need to check again why we have the issue with the completed, and let's scroll over here, and yep, so here the switch should be true, because we are doing we check the equality over here. So if true, it's true, then return boot. So in our case, it seems that it always falls back to this one. So let's try to make to create a new item, which will have the updated the changes that we did. So let's say go to the park, go for a walk, right? And we create the item. You see that we get the valid structure over there. And if we try to get to do's, to call the get to do's, right, we get both of the items, and that's fine. So that's the issue that we had from before. So now if I try to pass a limit to check the current parameter that we created, we get a single item, and that's working okay. So if we don't set anything, it falls back to 20. So we got 2. Nice. Let's continue filling the delete to do, and it's very similar with get to do. So I'm copying the logic that I have on the get to do, and I will paste it into the delete to do. So here we create the schema, we validate that we have a GUID, and we check that a to-do item exists in our database. And after we verify that an item exists, we can delete it and pass the GUID to it and await for the response. So we may get an error. And if we get an error, then this would be a status 500 error, let's say. And after if the deletion is successful, then we need to return a status no content status code. We don't need to pass anything to it, and that's fine. So I can remove the input of status. Okay, and if I try to get the new to-dos, okay, I will try to remove this one and test the delete to-do controller. So if I try to delete, first let me make sure that the validation is working. And now if I try to delete something, we get an error that GUID must be a valid GUID. So let's check again the gets to do's, and let me see if I copied that correctly. And yep, so we get a 204, and if we check the get to do's, you see that we remove the item which was created at the beginning. Nice. So the last lambda we need to update is put to do. So I will simply copy the same code from get to do, put it over here, and we need to update it a bit more. So for put to do, we expect to get path parameters, and in the URL to get the path parameter that includes a GUID, right? And that's we have already set the functionality. But the one more thing that we need to set is also that in the body we expect to get some values that we will use to update the to-do item. So we need to create a schema for it. So with that, I will create a body schema, and we may get a title, right, and completed, and that's Boolean. So both of them, they are optional, but I shouldn't let users to submit a request without any data to it, and that to work okay. So if the user doesn't pass anything, then I need to make something, one of those two options as required, and we can use joy to make that validation. So when completed is available, so Boolean and exist, then make the title optional, otherwise make the title as required. So that's fine, and let's make the validation within our controller now. So body schema validate and event body. So we need to check if we get an error. So that's body validation error. Cool. So if we have an error, we need to return a new response. Cool. And we are also checking that we extract the GUID. Okay, we know that at that point the body is available. We check that an item is available, and we get that to do. So the next step is to actually populate, call the put one to do item with the updated values. So here I'm just spreading the to do item, and in the title I will get the value from the body. Okay, so that's event body, and we see that we don't get the auto completion, and that's because we haven't set the type over there. So let's try to fill this one, right? And let's import to do, and in the body we expect to either have title and completed. So now we see that there is a title in the body. If the user doesn't pass anything, we want it to fall back to the title of the to-do, and we also have a completed, which if doesn't exist, we want it to fall back to the to-do completed. So now I can check the error, right? And that's the new to-do, which I will need to pass over there, and make a check of the error. And that if there is an error, it means that it's a 500 error. So we managed to fill that logic. So and we finish all the logic with all of our controllers. So let's try to test all of them. So we see that we have get reduce, right? And let's mark this one as completed. So if I use the put to do, right, body, and let's pass empty for a start, and we see that we get an error because we haven't passed a GUID. So let's try to pass a GUID and an empty object, and we get an error because the title now is required. So the logic in the validation that we added is working. So if I want to mark it as completed, so let's try to do it, and we see that it's updated and the new value is completed. If I get the items, we get the item created. If I try to get a single item, we get a single item, and if we try to delete an item, we see that we have successfully deleted it, and the get to is return a 404. So brilliant. We finish implementing our serverless backend locally. So the next step for us is to deploy our backend into AWS. We finish developing our API. So the next step for us is to deploy to our cloud provider. So before showing how we need to update serverless to have the right configuration, let's explore some of the commands that are available from the serverless CLI. So when we run serverless hub, we see that we have an option remove, which is related to removing a service which has already been deployed to the cloud provider. And we also have a deploy, which refers to deploying the service that you have on your framework to your cloud provider. If we inspect which commands are provided from deploy, we see that we have staged. So we will need to pass that parameter and set the value to prod. And we also have purpose. So if you want to get a full view on all the details related with your deployment, you can enable that flag. And there are a few other options that they are not related with the current tutorial. So let's move into package.json and try to create a few commands based on those what I show you. So we want to have a command something like deploy prod, and this would be serverless deploy stage prod. So this will deploy our setup into AWS, and another one is remove prod, which will run serverless remove and set the stage version to prod. So those two commands, we will use them to deploy and at the end remove what we have created in AWS. So now let's move into serverless YAML and see what we need to update. Locally, we created the table in DynamoDB manually, but serverless allow us to use CloudFormation within it and deploy other AWS services that we may want. And the way for doing it is by using the resource section. So the resource section runs CloudFormation behind the hood. So anything that you set within that section will run CloudFormation, and in our case, we will create a few resource for the DynamoDB table and an AIM role, which that role will be used from the Lambda functions and give them access to DynamoDB because our Lambdas, they need to communicate with DynamoDB, and we need to give them permissions so they can do that. I will copy the configuration that we will need, and that's this one. and let's have a look of it. So in the resources we see, so let's go one by one. So we set a Lambda role. So that role, as I said, will be used to give access to the Lambda functions and communicate with DynamoDB. We have an assume role policy, and we have a policy that gives those permissions. So the permissions are related to listing tables in Dynamo, get an item, scan an item, delete an item, and put an item. We give some permissions to CloudWatch so that they can create some logs if they need to, and we give access to invoke the function as well. So this role needs to be assigned to our Lambda function, and the way to do it is by coming into the provider section and in the IAM set the role and use a CloudFormation syntax to access the ARN of that role. So if you're not familiar with CloudFormation, so CloudFormation, it's the service provided from AWS so that you create services in them programmatically, and they have, it has its own syntax, and that's its syntax on how you can access the ARN related with the Lambda role. So now we can come down and check the to-do table, and here we set the to-do table, and we set the name, we set the attribute definitions, the key schema, and provision through output. So I need to update it so that it includes the new name of the param. So that's AWS DynamoDB to-do's table name. And here we set a few outputs. By default, serverless will output the result of the deployment, but we can also extend the output by setting our own output, and in our case we want to reference the to-do table and the Lambda role ARN. That's everything we need. So now we can continue with doing the actual deployment. So I want to remind you to configure your AWS CLI, because serverless read your credentials from, by default, read your credentials from your AWS config. So in my case, I created a dedicated user for this tutorial, and as you see here, that those are the credentials, and I'm also I will be deploying to US East. So now we can deploy to prod, and we can run the command npm run deploy prod. So the deployment, it takes a bit of time. The amount of time, it depends on how many services you need to deploy, and I will stop the recording until the command finish with the deployment, and I will come back when everything is done. The deployment is done, and as you see in the output, serverless printed a few things for us. So it includes the endpoint and also the functions, and in our case we need to get the base URL. So I get the base URL and come into the environment of that I have created at the beginning. So I replace it with the base URL and set the stage to prod, because as you see here we have prod. Save it. So now my endpoints will be pointing to the prod environment, and let's try to check them. So when I call get to do's, I get 404, and that's what I expect because I haven't created anything. If I try to create an item, let's say go shopping, I make the call, I get 201 status code, and that's the item that I have created. So let me copy the GUI. If we get the to-dos, we get the item we created. If we come here and try to make a call, we get 404 because the GUI doesn't exist. So if I replace it with the valid one, now we get a 200 status code. Let's try to update the to-do item. So here in the body, I have completed to true, make the call, we get the updated item with the value set to true. And if we verify that by calling the get to do's, the completed is set to true. So now let's remove the to-do item we created, and we get a 204 status code. And if we check the get to do's, we should get a 404, and that's what we got, because there are not any items available now. So we managed to deploy the endpoint. So now let's try to clean up everything that we have done, and that's npm run remove prod. So if you want to remove anything that you created in your cloud provider, then by running the command should clean up everything. So that was the end of this tutorial. I hope you enjoyed it. Serverless is a very powerful tool, and it takes time to really understand the concept and idea behind it, but after you get some practice and experience with it, it's a really nice tool, and it's recommended to be within one of your skills. So if you want me to make more tutorials on serverless and more complicated one, because in our on this crash course we cover a basic to do API. So if we want to cover more complicated concepts using SQS and SNS services, then please put a comment down on the video. I hope you enjoyed it, and speak to you next time.